Hi, I'm Steph Chavez. Today we're going to talk about design for space. And when I refer to space, I'm talking about outer space, such as satellites and space aircraft. Designing for space is designing for extremely harsh environments where failure can and has led to loss of life. Understanding how to design to spec and then doing it to spec. If you're designing for space, you should be aware of the NASA Electronic Parts Packaging Program, NEPP. The NEPP program generates technical knowledge and recommendations for just about everything within the context of NASA's spaceflight mission and hardware. On the NEPP website, check out the webpage Printed Circuit Boards, a NASA Perspective. A good reference to tap into when designing for space is NASA's PCB Working Group, PCBWG. It's a resource to NASA for printed circuit boards. The working group covers just about everything when it comes to printed circuit boards. The difference between a standard design versus a design for space is that the design for space, you must demonstrate that your design works before prototyping. That means you got to do simulations to the nth detail, you got to do modeling, you have your digital twin, you have a digital thread, you have to do emulations, peer reviews. I mean, it just goes on and on to the level of detail that is required when you're designing for space. When designing for space, you must understand that there are specific materials that are required to use when you're designing for such harsh environments. Typical PCBs that are designed for space are rigid PCBs that are polyimide based and glass reinforced. No floating copper. Making any kind of change in the design can't be done without the proper documentation and approvals. There's no room for the "that's okay" mentality. Tray spacing and widths are just not determined by PCB fabrication yields. IPC Class 3 is the class that you should be using when designing for space. A good IPC spec to start with is IPC 6012 Space and Military Addendum. It provides IPC Class 3 exceptions for environmental conditions that PCBs are subject to in space applications. The industry IPC 2200 series standards are commonly used to guide design for high reliability PCBs. When designing for space, it's even more critical that you have close collaboration between engineering and fabrication and assembly. You'll also have to use qualified suppliers that have demonstrated the ability to comply with IPC standards as well as MIL standards. Everything is critical. It's extremely important that you have constant communication between multi-domains and multi-disciplines. Ultimately, it's important that you understand that people's lives depend on you doing your job correctly. There is a significant cost difference when you're designing for space. Designing for space is significantly more expensive. You don't get to amortize or spread out the costs between multiple units. Commercials that are needed to survive such harsh environments can typically be 100 times the cost of the standard industrial or commercial grade component. The higher level of quality and reliability when designing for space increases the constraints and requirements for both fabrication and manufacturing. Therefore, the cost significantly goes up. Thanks for tuning in. I hope you now have a better understanding of the value of designing for space.